Often we want to determine whether two independent populations have the same variability. By testing variances, we can detect differences in the variability in two independent populations. One important reason to do the variance analysis is because remember we had two different t-tests previously in this chapter. One was pooled variance t-test and one was separate variance t-test. In the pool variance t-test, we assumed equal variances, and the separate variance t-test, we assume not equal variances. Now, if we know the result for the variance test, then we will know better which test we can use. If we find out the variances are equal or not significantly different, then we can use pooled variance t-test. If we come up with the result that the variances are not equal, then we can use the separate variance t-test. Now let's look at this example. Do 850 gram cereal boxes have greater variability in their weight than 475 gram boxes? Now the results of the study, so they pick 4 samples from 850 gram boxes and 15 samples from 470 gram boxes, and they take the variance for each sample. So for 850 they found 40.917, and for 475 gram boxes they found 16.714. Now the problem here is to test if this, so we can see the difference. There is a difference between two sample variances, but is this significant difference or not? That's what we need to test. Now the hypothesis test process is the same here. We start with setting up the hypothesis. Now once we set up the hypothesis, there is one rule here which is very important for this test. The variance, the highest variance should be always the first place. The larger sample variance is always in the numerator, which means once you set up your hypothesis, it should come first. Now that's why 850 gram should be first. So always, once you set up your hypothesis, the larger sample variance should be in the first place, which means it is going to be on the numerator right here. So the reason, because this test has only right tail, there is no left tail, and there are two tails, but there is not right tail, there is not left tail. So the next step is to find out the critical value. So there's going to be only one critical value here. This is right tail. So the function we use for critical value is f dot inv dot rt. Please take a note. So this is an Excel function to find out the f-test critical value for comparing the variances. So f.inv.rt. Now the probability is given 5%. So alpha assumed 5%. Degree of freedom for the first group, which is the numerator, sample size -1, which is on B14. So there are 4 samples, -1, 3, so B14. And degree of freedom for the second group, sample size of the second group, which is 15 minus 1, 14, which is, it is here on cell B15. So I put B15 here. Now once I click OK, so then I find the upper critical value, which is the right tail. I want to show this to you here, bringing up the graphic here, so you can see. Okay, now the critical value is 3.3439. So any number greater than this for the F test will be H0 reject, H1 accept. Any number less than this 3.3439 would be H0 accept. So all we need to do is to find the F test value, which is pretty easy. Standard variance of the first sample divided by variance of the second sample. So F statistics, B7 divided by B10, because B7 is for sample variance of the first group and B10 is the sample variance of the second group. So the decision here is H0 accept, because it is on the left side of the critical value. H0 accept, so there is no difference in the variance of these two samples. 850 gram or 475 gram boxes are equal variability. They are not different. Even although we see a difference between sample variances, but this is not statistically significant. Again, for this test, one important point is the larger sample variance always in the numerator, which should come the first. So if, for instance, if 850 gram variance was less than 475 gram variance, we should switch this data. So the data with larger variance should come first.